Hi, my name is Herman Chandi. I'm a co-founder and COO of UrbanLogiq.
Hi, my name is Jesse Mintz-Roth, and I'm the Vision Zero Manager at the San Jose Department of Transportation.
Today, we'll be talking about the road to zero, lessons learned since adopting Vision Zero in the city of San Jose, California.
We've been working with UrbanLogiq since 2018. The Vision Zero program began in 2015, and that's when the city adopted the initiative. We created our first high injury network in 2015 and updated it in 2017. But that was around the time we wanted to get into the data in a more analytic way. And that's when the city of San Jose IT department came across UrbanLogiq, and UrbanLogiq at first did a demo project with the city. And as we worked more on Vision Zero, particularly after we introduced our most recent Vision Zero action plan in 2020, we began working together more closely. And that's where the city was able to bring a lot of its data together in the UrbanLogiq platform. And most of the presentation today will be about our most recent work, updating our high injury network. That work was done in 2023. It should be noted that Vision Zero is a data-focused initiative. We are looking to understand our data very well and also understand our projects very well. And so we need to know that our projects are reducing. First off, we need to identify our projects. And secondarily, we need to continually understand them and know that they are reducing injuries. So we take the data and then we've layered the data. For example, our main data source is crashes and injuries from the police department. And we'd like to compare that by layering it with other city data of many types. Much of it is originally we were looking at data from the Department of Transportation, such as volume data. But over time, we've been looking at other types of data, such as equity data or data from other city departments. And it's important that we use data that's recent. So we like to look at 5-year data because single-year data is not necessarily showing a trend. But when we look at 5-year data, that's our standard analysis time frame. And we want to make sure that our data is for the most recent 5 years. So we've made the practice of updating our high injury network every 5 years, and this project was our update.
Great. So I'd like to introduce UrbanLogiq. UrbanLogiq is a data analytics platform that helps break down data silos in order to provide a more complete picture of the community, a complete picture of mobility and safety. This allows governments to analyze insights and make better decisions around, for example, countermeasures to improve safety in community. We serve communities of all shapes and sizes, and we help public officials who are very busy with their day-to-day do more with less. What do we mean by that? We know that governments often have to deal with data sources that are very difficult to analyze. They may be produced in PDF or CSV or Excel formats or come from APIs. We take that labor-intensive process of analyzing that data and shrink it down from months and hours to minutes. And so the result there is cities can automate their workflows, perform more insights at a much rapid pace. So there's a couple things involved in this journey here. The first is building trust. San Jose, in analyzing and creating their Vision Zero plan, needs to make sure that the data sources that go into a Vision Zero plan are clean and effective. And so by working together, we break down data silos and make sure both parties understand the data and the data that's going into Vision Zero plan.
On the city side, it's quite challenging to hire data science professionals. We have, a small number of people who do GIS, but it's not a very common skill set. And we have even fewer people who have a background in data science. So we were interested in working with a company that would be able to supply data scientists as a service so that we could analyze other methodologies used in other Vision Zero cities to see how they would affect our next version of the high injury network.
And in establishing the high injury network, our goal here was to use a holistic approach and a data-driven approach to generating a high injury network.
And so once we had generated some possible versions of the next high injury network, we then took it through a vetting process in the city, working with our top stakeholders in the Department of Transportation and also with our elected officials to figure out what would be the one to pursue.
So in terms of the collaboration path between City of San Jose and UrbanLogiq, the first step was for us to understand the state of the 2017 high injury network. We weren't starting with a blank canvas here, and the city had already established a previous high injury network. So it was critical for UrbanLogiq to understand how that high injury network came together.
So it was important then to work together to figure out how we were going to align to find what we wanted out of the process.
And in this process, when analyzing data sources that ultimately culminate in the high entry network, the goal here is to build trust in the underlying data sources, to speak about the data types and the temporal properties of data, the spatial properties of data, to make sure all parties understand what's going into the high entry network.
And so we then used that to generate a data model to create the network update. And we had at this point, worked together enough to have our personal relationships and our working relationships to do this.
When looking and generating at high entry networks, there's a process to generate a data model to essentially ensure that the high entry network takes into account many different data sources. And that's what we mean by breaking down data silos. So crash data was obviously mentioned. That's a key source. But we also look at things like road segment shapes. We want to make sure we define the length of segments correctly. There's a lot of consideration into defining the corridors in the high entry network. You want to look at intersection data. There's a lot of contextual data. We talked about land use and equity as examples. We want to know the implications in defining a high entry network in terms of community and project prioritization. There's also reviewing other methodologies. And finally, taking into account the previous work in generating the 2017 high entry network, how does that impact in generating the new high entry network? So this is the approach to generating a data model. And each of these data sources comes from potentially alternative systems and have considerations in terms of trustworthiness of data. So the process here is to create a unified data model that ultimately feeds into generating the high entry network. In the case of generating City of San Jose's high entry network, we looked at 5 years of the latest collision data. So we went from 2017 to 2021. We then generated corridors using the city's data sets, particularly combining road segments. And as you see on the right here with the map that's shown. And then we integrated the equity layer as well to see how high entry networks layered and correlated with communities of concern and equity focus areas within the city. So ultimately, we had our inputs as described in the data model. We had our crash data, ADT volume data. We had all this context information. We had equity data. And our output was to generate a list of high priority locations and their associated risk levels.
Working with UrbanLogiq, we tasked them, specifically their data science team, with reviewing 3 methodologies that are used by other California Vision Zero cities. And those methodologies were in a document that San Jose was a contributor to in 2021, which is called the Recommendations for California Statewide Guidance on High Entry Networks. And it was published by the Southern California Association of Governments, or SCAG. In the first version, the first methodology, we looked at fatal and severe injuries, which are abbreviated as KSI, and we were looking at their frequency. So we wanted to see the total number that had happened on each corridor. In the second version, we were looking at fatal and severe injury density. And so that was taking the total KSI number on each corridor and dividing it by its length. And in the third one, we were looking at a methodology that combined fatal and severe injuries with also minor and moderate injuries. And so the collision severity index method takes the fatal and severe injuries and multiplies them by 3, and then also adds the minor and moderate injuries and multiplies them by 1, effectively a weighting scheme. So the chosen methodology was the third one, the collision severity index, which is the weighted one, where you have fatal and severe injuries multiplied by 3 and the minor and moderate injuries multiplied by 1. And so you can see here the Vision Zero corridors, the old ones, which were from 2017 in purple, and then the new ones from this method in orange. By taking on this method and also looking to see how much of a coverage of fatal and severe injuries we wanted to keep, we decided to expand the network to go from a 3% coverage before to 6% coverage after, and also to keep all of the existing high injury network corridors that were in the last map, even if they didn't make the cut using the methodology alone. You can see here, this shows the resulting map and also shows crashes aggregated by intersection. So you can see larger circles on the intersections that have more crashes. And there's also some color coding on this map. So fatal injuries are shown in red and severe are in orange. The new map has 6% of the city centerline miles, and it covers 147 miles on 31 corridors, which is roughly twice as large as the previous one. And this 6% of roadways includes 46% of fatal and severe injuries, which is an increase from the previous map. There's also a large overlap on these corridor locations with equity areas identified by San Jose's equity index. This is San Jose's own city method for identifying equity areas. And so there's a 68% overlap with those areas. And it really shows us, that these two types of things overlap a lot. And that is the focus of the Vision Zero program to a large extent. And this also just shows the 2017 map versus the 2023 map, the old method and the data years versus the new method and its new data years. So the new map uses data from the 5 years of 2017 to 2021 and covers 46% of fatal and severe injuries, and the mileage is roughly 150 and roughly 6%. We have an example of the type of project that we are doing on these types of streets. So this is the Center Road project, and this was completed in 2021 in quick build, and you can see the before conditions on the left, sort of a wide open road, and then the after conditions on the right. And this project is a road diet. And so here you can see the new configuration is basically consistent. On the left, you used to have to merge over into a bottleneck. And on the right, the 2 lanes are consistent throughout. And in this bottlenecked area, it's just continually going straight in the 2 lanes that exist. This type of project is known as a quick build project. And we now have a team that specifically builds these. And this is the sort of it's the most growing type of our work in the city of San Jose DOT right now. And the streets that are designated by the high injury network as we update it are the streets that will receive projects like this in the future. They won't all have this exact design, but the materials that are used here, paint and plastic, are the main materials in San Jose's Vision Zero priority corridor redesign.
So you've seen an approach where we're breaking down data silos, and a trusted partnership between the City of San Jose and UrbanLogiq has led to the creation of the new high injury network. In terms of looking to the future, there's many exciting possibilities of where this can go. The first is that with this high injury network and the various other data layers that UrbanLogiq deals with, for example, projects and countermeasures, there's a possibility of using data science and machine learning to help the San Jose Quick Build team recommend specific projects and measure the effectiveness of projects. We're also set up in a position now to potentially do automated analysis as well. So generating the high entry network perhaps on an annual basis is a possibility, resulting in a more continuous cycle that was mentioned earlier versus waiting every 5 years. We're also able to measure the impact of countermeasures as well. And in the future, we'll be able to guide San Jose using machine learning models and potentially data science to understand the benefit and cost analysis of specific Vision Zero projects as well. I'd like to thank you for attending our webinar. My contact information is available here.
It was great to work with UrbanLogiq on this project, and you can contact me at my email on this slide.